Question number 4, we have a 40 kilogram mass being pulled by force P at an acceleration of 2 meters per second squared. It's connected to a 10 kilogram and a 10 kilogram and there's friction. Okay, so label all the forces on the diagram. Choose a color that's going to be different to the diagram. I will have 3 weight forces. Those weight forces will be mass times acceleration, so 10g, 10g, and 40g. I have my P force. Don't draw it again, there's only one of them. We will have a normal reactive force. I'm going to call that one N3, I'm going to call that one N2, I'm going to call that one N1. Don't call them all N because they're different values. We're going to have tension in this string going in that direction from this back mass, call that T1, and I'll have tension going in the opposite direction connected to this second mass. I'll have T2 and I'll have T2. And I've got friction. This back object on the ground will give me friction, which will be 0.5 times N1. In this middle mass, we'll also have friction going as the opposite direction of motion, which is 0.5 times N2. And this one will also have friction, which is 0.5 times N3. So they're all the forces that I have that's going on in this particular situation. Friction 1 will be mu times N1, which is 0.5 times 10g, which is 5g, or you might write that as 49 newtons. F2 is mu times N2, which is 0.5 times 10g, so that's also 5g, or 49 newtons. And F3 will be 0.5 times N3, which is 0.5 times 40g, which is 20g, or 196 newtons. So there are my 3 ways. Consider each mass separately, or you can look at the whole system. I'll look at each mass separately, then I'll look at the whole system as an example. So each mass separately, so if I look at the back mass, I'm going to have resultant forces in the direction of motion, which is to the right, will be equal to T1 minus anything opposite, which is 5g. Therefore, 10 times 2 equals T1 minus 5g, or 20 plus 5g equals T1. So T1 equals 20 plus 5g, or you could write that as 69 newtons. Looking at the middle mass, anything in the direction of motion, the resultant force will be T2 minus T1 minus 0.5 N2. So 10 times 2 equals T2 minus T1, which is 69, minus 0.5 times N2, which is 49. Therefore, T2 is going to equal 20 plus 118, or 138. Which means then when I look up my front, any resultant force in the direction of motion will be equal to P minus the 2 things going in the opposite direction, which is T2 minus 0.5 times N3. So therefore 40 times 2 will equal P minus, what was it, 138 minus 196. Therefore P equals 80 plus 138 plus 196. P equals 414 newtons. If I wanted to consider the whole system, okay, the whole system, then the resultant force in the direction of motion will be any forces in the direction of motion, which is P plus T2 plus T1 minus any forces in the opposite direction of motion, which is T2 and T1 and F3 and F2 and F1. Which means that the mass will, so the resultant force will equal mass times acceleration, and there are three masses that are being moved. So 40 plus 10 plus 10 times 2 equals P minus F3 minus F2 minus F1. So 120, so that's 40, 50, 60 times 2. So P is equal to 120 plus 196 plus 49 plus 49, which gives you also 414. So yes, you can look at the whole system and look at all forces in the direction of motion minus all forces in the opposite direction of motion, and then look at the collective masses, or you can look at it separately for each of the particles.